Welcome to our new video of atom. Some of you might be thinking, why are we even discussing atoms, and what it has got to do with us, and with our world? Let me tell you this again, everything in this universe is made up of atoms, and every material's core property depends on its atom. So if we can know what actually is an atom, and how does it behave, then we can predict the whole property of an element, or a compound, or even a material based on its atomic structure. To know how the ideology of an atom was taken, and how was its model described previously, follow the link given below in the description box. As for now, we will be focusing more on Plum pudding model of an atom, which was created by Sir J.J. Thomson in 1904. Until now we have come to know that everything is made up of atoms, and also atom is indivisible. But the model put forward by Sir J.J. Thomson said something else about an atom. Sir J.J. Thomson in his cathode ray tube experiment finds that there are things much smaller than atoms. These things smaller than atoms were not discovered, and were not explained until the cathode ray tube experiment was performed. Let us see what is a cathode ray experiment, and how this experiment helps in further shaping the model of an atom. A cathode ray tube experiment includes a glass tube that is completely vacuum, and inside that tube, two pieces of metal are fixed at the end. Also, on the side of that tube, two metal plates are placed, and this metal plate is conducted to electricity. So the upper metal plate is positively charged, and the lower plate of metal is negatively charged. Sir J.J. Thomson found out that when a power source was connected to the pieces of metal, a ray was emitting out. These rays are actually called cathode rays. And this cathode ray was moving throughout the tube at a faster speed, and it can be seen glowing at the other end of the tube, when it hit the tube end. Also, he notices something really strange about this ray. He notices that this ray was actually deflecting toward the positive charge plate metal on the side of the tube. J.J. Thomson studied the cathode ray tube's experiment, and he also knew that similar charges repel each other, and opposite charges attract each other. So he came up with the idea that the particles in the cathode rays must be negative, because they were attracted by a positively charged plate. This also meant that the ray was negative in charge, and that it must consist of small particles that have mass. Thomson also measures the mass of this tiny particle, and he found that the mass of this particle was 2,000 times smaller than the mass of the smallest atom, the hydrogen atom. This super tiny particle were later renamed as an electrons. With this experiment, Thomson disproved Dalton's atomic theory, since Dalton's claimed that atoms are the smallest particles of matter. Clearly, the presence of electrons negated these portions of Dalton's atomic theory. From his discovery, Thomson also inferred that electrons are fundamental particles within atoms. The discovery of the electron suggested there was more to know about atoms. Thomson's work revealed that electrons are negatively charged, but he knew that atoms themselves had no overall charge. And he reasoned atom must contain positively charged particles to cancel out the negatively charged electrons. So, Thomson developed a new model of an atom, in which the electron was embedded inside a positively charged sphere. This model of an atom looks similar to plum pudding, and the electrons in the model look like the dry fruits embedded in a sphere of positive charge, just like a spherical plum pudding. The model of an atom has also been compared to a watermelon. The red, edible part of the watermelon resembled the sphere having a positive charge, and the black seeds filling the watermelon looked similar to the electrons inside the sphere. This was Thomson's model of an atom. And it was unable to explain the scattering experiment of Rutherford. It also failed to explain an atom's stability, since his theory did not mention anything about nucleus of an atom. To find out how nucleus was discovered, hit the bell icon, and never miss an update from our channel. And if you have not subscribed our channel, please subscribe. Till then, peace.